Chickens? I'm all about chickens. Yes, put chickens in the shed. Great idea. So, what do? Studies show that if you model the problem with the 4 boxes, it makes it easier for you. You do whatever you want. This is how I'm going to do it because I have to teach. So, I draw this rectangle. It's divided up into 3 sections. There's my 3 sections. Anybody want to give me an idea where to go now? Ooh, good. I got a width, a width, a width, a width, and a length, and a length. So if you notice, I've tried to set you up with the problem we did last year. So. Okay, great. Kitty is 100% correct. Before we do that, we're just going to make sure we know where to start. Where you start is right here. Maximize the area. That's what's driving the problem. The area function, folks. What is area of a rectangle? Great, but I got 2 variables. No good to have 2 variables. What I need to have is 1 variable. So we're going to insert Katie's knowledge, which is this. Take the 4 widths plus the 2 lengths, and you get 480. Yes. You could do that too. So you'd like to put the W's here and the lengths here? Oh, you could do that. Yep, you could, and the problem will work out just the same. Okay, all right, so I'm going to take the 2L here. I'm going to subtract the 4W. I've got 2L is equal to 480 minus 4W. And now I'm going to divide by 2. And you can see that what I get is L is 240 minus 2W. What the heck should I do with that? And the whole idea is I plug it in so I could get rid of 1 variable. I now have, or I could get rid of 1 variable, so now I'm left with just 1. I have the area in terms of what? The width. Area in terms of width is 240 minus 2W times W. So that's my equation. The area in terms of width is equal to 240 W minus 2W squared. Yes. You could do that as well. If you like to do area in terms of L, that's fine. Problem will still work out. So this is where you have to think conceptually. Maximize the area. Our goal is to maximize. What shape does the graph make? Parabola. Right side up or upside down? Does it have a maximum or a minimum? It has a maximum, right? Well, that's awesome. We can find the maximum. Yeah, that's the goal. Maximize. How do you find this spot of a parabola? Because you know it's a parabola, because it's squared. And because it's negative, it goes upside down. So it's going to have a largest spot, not a smallest spot. What'd you say? Close. Negative b divided by 2a. But we're in calculus, so we don't need to do that garbage anymore. What do you notice about this spot, everybody? That's where the derivative is 0, right? So take the derivative. What's the derivative? No, what's 240 minus 4w is equal to 0. So if you did negative b divided by 2a, which is the formula for the vertex of a parabola, you could do that as well. But I'm going to do 240 minus 4w is equal to 0. And I get 240 is equal to 4w, or w is 60. What does that tell me? The width is 60. 60 what? 60 yards. What is the question asking me to determine? What dimensions? That showed me the width. The width is 60. How do I determine the length then? it looks like it says that the length is 240 minus 2 times W, right? So if I plug it in, I get 120. 240 minus 120 is 120. So Herfindahl Farms is going to be able to build a pen now. So they got some good free-range chickens going on. It'll increase their business. They're going to build the pen 60 yards by 120 yards, divide up into 3 sections. Why 3? I don't know. I guess they want to separate the chickens because bad blood. They don't want bad blood. They want good blood. Nobody makes me bleed my own blood. Dodgeball, thank you. Yeah, I was looking for that. Farmer Herf, he's going to build a fence, but he's going to put it up against a barn because he doesn't have enough fencing to use 4 sides. So if he builds up against a barn, he only needs 3 sides. He's got 320 feet of fencing. He needs to maximize the area. You guys go ahead, take the problem as far as you can with a partner. Go. Good. So follow your formula. 320 minus 4W is equal to 0. Divide by 4, you get 80. Plug it back in, you get 160. Notice that the width is half of the length. That's not always the case. It did work out that way in our first 2 examples, but will not always work out that way. Okay? All right. So let's go to a classic problem. A box with an open top is to be constructed to form a rectangular piece of cardboard with dimensions 18 by 10. And you're going to cut a square piece from each corner and fold up the sides. You want to find the largest volume that the box can have. So we have this piece of cardboard that measures 10 by 18. You're going to cut I'll call it X. Cut X from each side. So you're always wondering where to start. The problem tells you where to start. It tells you where to start when it says maximize or minimize. That's what tells you it's an optimization problem. That's what tells you that you're going to find a derivative instead of equal to 0. So right now we're saying in the middle of this, so you guys are always like, oh yeah, we take the derivative instead of equal to 0. Well, how would you know that come the AP exam? Well, as soon as it says maximize or minimize or largest or smallest, that means optimize. So largest volume. That's the setup. That's our focus. How do we determine volume of a box? Yeah, so length times width times height. We multiply all those together. Well, I got 3 variables. I got to get rid of something. Anybody give me an expression for the width? 10 minus 2x. Does everybody see that? So when we fold up these corners, you're getting rid of that space and that space. So it was 10, but you're subtracting off x and you're subtracting off x. So the new width is going to be 10 minus 2x. Suppose you cut a 1 by 1 square. All right? So this was 1 here, and this was 1 here. So this was 1 here, this is 1 here. So our width now, instead of being 10, is going to be 8. Yep. So now we're going to determine the length. What's the length going to be? 18 minus 2x. Whatever x is, multiply it by 2. That's what we get rid of. What's the height going to be? Just x. as you fold it up, as you fold up this side, it's going to have a height of whatever you cut. All right, so now we need an equation. We've got the equation, but I'm just going to multiply it out so we can see it a little bit better. Okay, so let's distribute some of these pieces through and see what we get. Volume in terms of x is, let's see, so I have negative 2x times negative 2x times x will give me 4x cubed. I have negative 2x times 10 and negative 2x times 18. Let's see, 2 and 18 makes 36, and then 2 and 10 makes 20, so negative 56x squared. Okay, Dylan. I appreciate your high expectations. All right, and now I multiply the 10 by 18, I get 180, so I get 180x. Do you know what that looks like? How many places does it have a derivative equal to 0? 2. Are we trying to maximize it or minimize it? We're trying to maximize it. So you're looking for this spot. We take the derivative. What's the derivative of 4x cubed? Remember when that was what we were doing in class? Like, hey, let's take some derivatives. Yeah, that was actually, we made some mistakes because we're trying to find the derivative of things like, 3/5 roots of, x squared over 5, what's the derivative of that? So we threw in some fractions of radicals, but yeah, we're just taking a derivative, no big deal. 12x squared minus 12x plus 180 equals 0. Is it factor? How about we just use our calculator? If we got the quadratic formula built in our calculator? It's not. I'm not as good as you. You're good at everything. I'm good at nothing. Okay, who did the quadratic formula? What'd you come up with? 2.06. Okay, folks, this is really important here. We got 7.27, 2.06. What does that mean? You tell me. Chris? There's a local max and a local min. Which one's the local max? Are those x values I found or y values I found? They're x values. So x being 2.06 is right there. X being 7.27 is right there. You want the smaller one because that's where the maximum occurs. The bigger one is where the minimum occurs. Does it make sense as you think about the graph? Okay. Does that answer my question? What's the question asked for? The largest volume. What we found is the size of box that we should cut. We should cut a 2.06 inch box off of each corner. So what do I do to find the volume? Plug it into what? Into the volume formula. When do we plug into the volume formula? 2.06. So take my 2.06. I got 4 times parentheses 2.06 cubed minus 56 times 2.06 squared plus 180 times 2.06, 168.13. You guys are really smart. Yes, Kaylee. Kelly asks an A-plus question. Give her a round of applause for asking such a great question. Way to perform. I agree. All right, Kelly's question was this. Why do we plug it into this one, whereas in the other one we use the stuff in the second box? The answer is this. What are you trying to determine? Watch. In this problem, it says find the largest volume. Volume is sitting right here, right? It says volume equals. Now, Kaylee, if you would plug it into here, it'll give you the same result because this is the same as that, right? No, 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 no. It's not dumb. Don't say it's dumb because, no, because watch what happens here. Okay, here you guys came up with 80 by 160, right? So you took that 80 and you plugged it in here because you were looking for the length, right? Well, if the question was find the area, you would plug it into here because it says that's the area. See it? So just identify what you're finding and then say which one tells me that piece. Point of confusion all the time for people. Thank you for asking it. Flip it over. Find the dimensions that give the largest area for rectangle whose base is on the x-axis and whose corners are at, or who are on, sorry, the parabola y equals 12 minus 3x squared. I think I've done enough work. You guys take me through this one. Draw what, Braden? A rectangle? All right, before I draw the rectangle, what should I draw? A parabola. Okay, Braden says draw a rectangle inside the parabola. I'm all about that. Great, cool. Okay. Tell me more. Elaborate for us. I believe in you. I'm in suspense. Oh boy. Good. How do we come up with 2x? That would have a coordinate of x. That would have a coordinate of negative x. So the distance between them is 2x. Everybody agreed? The area is still equal to the base times the height. What is the length of the base? The base is 2x. Good. What's the height? Good. The height is y. So now your equation is area is equal to 2x times y. Shoot. I've got two variables still. That didn't work out. I should quit. What is y? Y is 12 minus 3x squared. So area is 2x times 12 minus 3x squared. Or the area is 24x minus 6x cubed. What shape does it make? Except it goes the other way, doesn't it, folks? The cubic is negative. We're looking for a maximum or a minimum? We're looking for a maximum. What do? Because it says find the largest volume. Find the dimensions that give the largest volume. The largest area, excuse me. Take the derivative. What's the derivative? Set that bad boy equal to 0 because that's where the derivative is equal to 0. (24) equals 18x squared. I'm going to take the 24. I'm going to divide it by 18. See what I get? I'll take the square root of that. I get 1.15. So x is 1.15. Let's answer the question. What's the question asking for? So what's the base? 2.3 what? Oh, we don't have any labels, do we? So base is 2.3 and height is, how do I find the height? Plug in what? It's the same thing as y, so we go 12 minus 3 times 1.15 squared. And hey, stop that. $10.68. Oh. Are you telling me that I made another mistake? $8.03. We're good now? Plug it in. So you found out that x is 1.15. We want to know the base and the height. The base says take 2 times x. The height is y. And what is y? Y is 12 minus 3x squared. So plug in that guy. Is that better? We good? Who normally sits next to you? Oh, optional Thursday. Florida. It's code for sitting at home watching Netflix. Okay, let's do one more together, and then we'll call it a day. And tomorrow we'll get to problems we haven't done together before. Okay? What? For tomorrow? I don't think that tomorrow is very scary. A rectangle is inscribed in a semicircle of radius 16 inches. Except? There we go, Riley. Riley's a smart guy. That's why he's unknowledgeable. Hey, somebody else, tell me what to do. Areas base times height. Okay, I like it. I like it. Got a coordinate there of x, y. So we got this is x, this is negative x. You guys are like, this is the same problems we just did. Height is y. It's got area is equal to 2xy. Same stinking problem, right? Oh, we don't know what y is. What's the height? This is a problem that actually comes up in math sometimes. You say, what's the height? You say y. You say, what is y? You say the height. You say, what is the height? You say y. You say, what's the y? You say the height. And there are times in math I've come up with circular logic, and you got to get yourself out of it because unfortunately, you just get trapped. We are working with semicircles. Katie sees something. Okay, so YouTube, just to let you know the things that have come out of the mouths of these wonderful, wonderful students. I heard synthetic division come out. I'll try not to laugh at that one. We heard area of a rectangle. We heard area of a semicircle. But we also heard something called the Pythagorean Theorem, which I kind of like that. Yeah. And the reason why I like that is because, folks, what nobody has said so far, and this is what, nobody said the equation for a circle. Yes, you do! You say you don't know what it is. You do. It's just the Pythagorean theorem, right? That's all it is. Don't you remember the equation for a circle? X squared plus y squared is r squared, which is just the Pythagorean theorem. And if you don't see that, what is this distance right here if the radius is 16? 16. So you have x squared plus y squared is 16 squared. X squared plus y squared is 256. You told me that h is y. Can I now figure out what y is? I can. I have y squared is equal to 256 minus x squared. Square root both sides. Y is equal to the root of 256 minus x squared. Please be careful to all of you who want to take the square root of 256 at this point and the square root of x squared. It's totally illegal. Big time voodoo math. Just let it be. So therefore, my area is equal to 2x times the root of 256 minus x squared. This is what's awesome. Do you have any idea what shape that makes? You want to graph it on your calculator, huh? So if I take y equals, and I go 2x times the root of 256 minus x squared. And I'm going to go to my window, and I'm going to go, let's see. We'll go back to negative 20. That's not very good, is it? Looks like my window's a little bit out of range. I said the x value at biggest could be 16. Does that make sense? So I should probably think about the y value as the area. So I should think about that a little bit. Let's pick a value like 8. Okay, let's pick a value like 8. Suppose x was 8. What would the base be? The base would be 16. And if x was 8, we would have 256 minus 64, which is, about 200. What's about the square root of 200? Sure. Maybe about 15, maybe. So if you took 16 times 15, what do you get? Yeah. So maybe we should take our window, instead of our y values being negative 20, positive 20, maybe we should make it more like, say, 500. Let's see if the graph works now. Ooh. I get the plot off of there. You don't like the plot that I've got going on? What do you think about that? Hey, wait a minute. What if I also showed the negative one? That's the infinity function. Actually, I'm sorry. I said infinity function. It's definitely not a function. It's two parts that together can make that. Kind of like a bow tie. Pretty neat, huh? So does it have a maximum? It does. Let's find it. How do we find a maximum? We're going to run out of time. Take the instead of equal to. What rule do you have to use to find the derivative? Product and the chain. This is awesome. Not everybody can do this stuff. What's the derivative of 2x? Hey, that was easy. Times the root of 256 minus x squared. Say it again. You make me want to throw up. Well, I mean, you did kind of start it, didn't you? Yeah, it's okay. All right, we're you made Jake laugh, so All right. Plus 2x times, I got to find the derivative of the root of 256 minus x squared. How do I do that? Chain rule. Thank goodness for the chain rule, huh? I mean, what would we do without it? U to the 1/2. And I got 256 minus x squared. What's the derivative of 256 minus x squared? Negative 2x. What's the derivative of u to the 1/2? Remember when that used to be confusing to us? Now we're like, hey, 1 over 2 roots of u. Okay? Look what happens when you multiply these together. What happens to the 2's? They cancel, but I'm left with an x on the numerator and a negative. So times negative x over the root of 256 minus x squared. For a prime is equal to 2 roots of 256 minus x squared over 1 minus 2x squared over the root of 256 minus x squared. Folks, we're done with the calculus. We're to your favorite subject, which is algebra now. This is super easy. We all love algebra, right? So I got to solve this equal to 0. So I got to find what? Common denominators. What's the common denominator? Root of 256 minus x squared, right? So you end up getting, we're going to set the derivative equals 0. So you got 0 equals. If I multiply this by the root of 256 minus x squared, I get 2 times 256 minus x squared. Right? No, I don't have a 2 times 2. I just have that. Minus all over the root of 256 minus x squared. Combine like terms in the numerator, I get 512 minus 4x squared over the root of 256 minus x squared. Do I care where the denominator is equal to 0? Where is the denominator equal to 0? 16 or negative 16. Look at your graph. Does it make sense that it's 16 and negative 16? That's where the derivative is undefined? Because that's where you have a vertical tangent, right? So what we're looking for is this spot right here. So we have to think of where the top is equal to 0. So I have to solve 512 minus 4x squared equals 0. Well, that's easy, right? We just take 512, we divide it by 4, and we take the square root. We get square root of 128. Or 11.31. X is plus or minus 11.31. Do we want the positive one or the negative one? Why? Yeah, if you look at your graph, we want this one. We don't want that one, right? This is where the maximum occurs. So x is 11.31. So what's the base then? 22.62 what? Inches. And then the height is, how do we figure out the height? Plug what in for y? Yeah, so you get the square root of 256 minus 11.31 squared. Or you get 11 point, oh. Isn't that crazy? Huh. You know what it told us? It told us that this is 11.31, and this is 11.31. This is 11.31 as well. Turns out that if you have a square in each quadrant, that's what's going to maximize the area. It's pretty cool. There you go. I have a worksheet for you, and the worksheet is not going to be easy. Sir. Yep. Yeah. Here? I just looked at where that was equal to 0. So I took 512 minus 4x squared, set that equal to 0. So I divided by 4 and I square root of both sides. So 512 minus 4x squared equals 0. So 512 equals 4x squared. Solve there. Because you just want to look at where the top's equal to 0. Question? The graph? So if I go into y equals, I'm going to get rid of that guy. That was just the negative one, so it shows you the infinity symbol. Oh, well, the window, do you see how the x value needs to be bigger than 16? Yeah, since you have a radius of 16, it needs to be bigger than 16, right? So it says that the area is that. So your y value needs to be area, okay? So let's think about a possible area you could get, okay? So what do you want x to be? It needs to be a number between 0 and 16. What would you like? What? Well, you would get 0. I mean, if it's 0, think about it. If x was 16, then you would have a box with no height. So what would you like x to be? 10? Great. So we'll go 10 is the x value. So that means that the base would be 20, right? And then the height would be whatever the y value is. So we'll plug in 10. 10 squared is 100. 100 or 256 minus 100 is 156. The square root of 156 is about 12. So what's 20 times 12? 240. So that means my area is producing results that are in the hundreds. Because that's the length of the base. So you chose x to be 10, so that means the base is 20.